blood typing is a very important part of this chapter. Blood typing and blood matching. Remember I said earlier, if you ever need a blood transfusion, and the science, our ability in medicine and science to be able to take blood from one person and to give it to another person is simply amazing. And we take that sort of for granted. We think about that and we say, well, they've been doing it for years. I know people who have done it. As I said, unfortunately, my wife needed it when we had our second child. She needed a blood transfusion. She needed 2 blood transfusions, and then we decided after that that we were not going to have any more children by birth. So, but it's a wonderful thing that technology, that science is even available. That medicine is even available. And I encourage any of you listening to this, that if you are able to give blood, if you're not anemic, if you're not, you don't have any blood diseases, and you're above, I think you have to be above 110 pounds or something like that, and you can give blood, I would recommend you do so, because you can save a life, literally save somebody's life. I've seen it myself. Okay. So blood transfusions, blood taken from a donor is given to a recipient, right? This is a very common practice in medicine today. Right? We have discovered what we call these antigen surface markers. Antigens are found on most biological molecules, all cells, including erythrocytes, blood cells, red blood cells. And that has helped us develop these safe transfusion practices. Your immune system recognizes foreign antigens, right? Remember that, and tries to remove them. And so if we give you blood that has foreign antigens on it, your immune system will try to kill those blood cells. So how do we get around that? Some of you already probably know, we try to match the antigens from the donated blood to the person receiving the donation, the recipient. So antigens on the erythrocytes are genetically determined by carbohydrate chains, and they give rise to different blood groups. 2 groups of 30 different antigens found on erythrocytes are particularly useful for clinical use: ABO blood group and the RH blood group. So everybody's probably heard of A. Yeah, there's A, there's B, there's AB, there's O, then there's positive and negative. Everybody knows. So figure out your blood type. I think I'm O positive. I always forget if I'm O negative or O positive, but I think I'm O positive. So that's a good thing to know. I have it in my phone on my Red Cross donation app. I don't have my phone right beside me right now. All right, so here we go. Blood typing. ABO blood group features 2 antigens. All right, A and B give rise to 4 ABO types. All right, so a person type A blood has only A antigens. Remember, these antigens, surface markers found on the blood, primarily made up, these antigens are primarily made up of, as it says, where did I have it written down? I know I had it genetically determined carbohydrate chains. So the term genetic, remember, that is kind of important. Your blood type is genetic. It is genetic. It's passed down. It depends on your parents. Well, both parents. So depending on both parents, how your blood type is. So it is a genetic. These are antigens on the surface of your blood cells. Okay. like think of antigens sort of as, this is on the previous slide, I think I said markers. Yeah, surface markers, right? They don't really do a whole lot, but sort of mark the surface of the cell. But they are very important, right? So type A blood has A antigens on the surface. Type B blood has B antigens, right? That makes sense. Type AB has A and B antigens on the surface, and type O, which is me, I'm type O, have no antigens on the surface. Now, if somebody is type A and then they get blood from somebody who's type O, do you think that the type O blood will be accepted? Yes, it will be, because they will only fight off type B or type AB blood. Their immune system will fight off type B or type AB blood, because type AB has B antigens as well, and those won't be recognized by the body. But since type O has no antigens, then it has nothing for the immune system of the type A person to fight against. Okay, so that's the general idea. Then we also have RH group, RH blood group, which features this RH antigen. RH comes from rhesus monkeys. That's where it was first discovered. We do have similarities with monkeys. I'll leave that there. There are similarities. Individuals with the RH antigen, also known as B antigen, on their erythrocytes are RH positive, and those without this RH, also known as the D antigen, or RH negative. So you'll see RH or you'll see D. So ABO in RH or ABO, and you'll see D sometimes. So you'll see either one of those interchangeably used. Give rise to 8 common blood types, right? O positive is the most common blood type in the US population. That's me. And AB negative is the least common. That means you have A antigens, B antigens, and no D antigen. That's the least common. Blood typing uses antibodies that bind to individual antigens on erythrocytes. We mentioned antibodies a little bit when we were talking about the B and T cells. The B and T cells, they're part of the leukocytes, lymphocytes, the B and T. Remember that? So antibodies called agglutinins bind to the surface-bound antigens, cause them to clump together or agglutinate. That's important, agglutinate. Probably should have highlighted that. I'll go back and highlight that. Ultimately, agglutination promotes erythrocyte destruction called hemolysis. So antibodies bind to antigens on the surface of the blood cells, cause them to agglutinate, to clump together. And remember, sort of similar to coagulate, but in this sense, they're just sort of clumping together in a bad way, similar to that platelet plug and coagulation. But this causes the cells to agglutinate, to clump together, bind together, and which ends up causing these red blood cells. Remember, these red blood cells don't live long to begin with. It eventually causes them to hemolyse. Lyse means break apart, to break apart and be destroyed. Right, and this is a diagram of that, of blood typing. Right, so somebody has type A blood. No, if let's say I have a beaker with type A blood in it, and I'm asking myself, well, what type of blood is this? If I put anti-A antibodies into this type A blood, it will cause agglutination, so it'll cause it to clump together, and it'll eventually cause the blood cells to break apart. So that will tell me that blood, that type A blood, that blood is actually type A blood. That's how you figure it out. So a blood sample is treated with 3 different antibodies. So I take a blood sample, treat it with anti-A antibodies, anti-B, anti-RH antibodies, or remember that's also known as D. Agglutination indicates that the antigen is present on the erythrocyte, the red blood cells. No agglutination indicates that specific antigen is absent, right? So if I have anti-A antibodies, that means, and I get agglutination, that means that there were A antigens on that red blood. So that means that you have at least type A, or you could have AB. Same thing with B. If I have anti-B antibodies and I get agglutination, that means that blood's either type AB or type B. And also for anti-D and anti-D, which is anti-RH, right? So that's how you would type the blood. So if that same blood sample, if I got agglutination with the anti-A antibodies and the anti-B antibodies, now I know I have AB blood, okay? If I use anti-A and anti-B and I don't get agglutination with either one, then I know I have type O blood. Okay, I have neither antibodies on, and neither antigens on the blood. And it's the pictures of blood typing. You need to understand blood typing. You will see blood typing on the final exam. So know that concept. Blood transfusions. So the immune system recognizes antigens on erythrocytes as self-antigens, does not produce antibodies to self-antigens. So it will not agglutinate its own blood. If it did, that would be very problematic, because then if you started to kill your own blood, then you wouldn't be able to live very long. But the immune system does produce antibodies to foreign antigens. So anti-A, if you're type B blood, you'll have anti-A antigens in your body. I mean, anti-A antibodies in your body, so that if A antigens come into your body, that they can be removed. This means that antibodies are present in plasma only if antigens are absent from erythrocytes. Right? Note that anti and anti-B antibodies are preformed. They're present in plasma, even if individual has never been exposed. Right? So if you have B blood, then you already have anti-A antibodies in your body. Anti-RH antibodies, however, are produced only if the person has been exposed to blood containing RH antigens. Therefore, an RH negative individual generally has no anti-RH antibodies unless he or she has been exposed to RH plus erythrocytes. Antigens and antibodies are basis for blood matching. All right, so blood taken from the donor is screened for compatibility before we give it to somebody, right? Which makes sense. We don't want to give somebody blood that their body would reject, that the antibodies would cause agglutination and cause the blood cells to die. That would make no sense, right? So when you give blood, when you donate blood, which, like I said, I don't love needles at all. I don't really love donating blood at all, any part about it, except for the fact that I know that I'm doing something good for somebody and it can save somebody's life. I hate needles. They're no fun. But anyways, some people I know that are watching this video probably saying, "Oh, what's a little needle?" But now I don't like them at all. I have to look the other direction. But when they take my blood, and they already know this about me because they've already taken my blood multiple times, and so they already have my blood on file. They already know my blood type. But if I was a new donor, what they would do is once they took my blood, they would test it and see what type of blood it is, so that when it gets shipped to a hospital and a patient needs blood, they'll say, "Oh, that patient's type O positive. Let's give him some of this O positive blood donated by Professor Fisher." Actually, they don't care who it's by, as long as they have it when they need it. But patients cannot receive any blood containing antigens that his or her immune system would recognize as foreign. So a match occurs if donor blood type is compatible with the recipient. Right? Transfusion reaction, you can have a negative reaction, causes agglutination that destroys donor erythrocytes, and that could potentially lead to kidney failure and death. Remember, your blood passes through your kidneys, and we haven't talked about that. We will get to that when we talk about the urinary system. But if you have all this agglutinated, all this these agglutinated blood cells come into your kidneys, it can actually cause your kidneys to fail. The kidneys are necessary for the filtering out of waste of your blood. Well, now you've created all this waste in your blood, all these broken blood vessels in your blood, and so all this is going to come out. Want to come out at your kidneys can actually cause your kidneys to fail. We don't want that to happen. All right, so this is an example. You can go through this example on your own of a blood transfusion. Read through this slide. You probably have read something similar in the book. But it was, I've just told you an example, so you kind of have an idea of what's going on here already. If you still have questions about this, feel free to ask me. We can go over this. Donor type O negative. Blood match O negative donor and AB plus recipient. No agglutination. So you have, if a donor has O negative, that means no A or B antigens and no RH antigens. They can donate to the AB positive. They can donate to that person, and there's no agglutination because there's no antigens. Whereas donor AB positive, if they tried to donate to somebody who was O negative means you have A, B, and RH, anti-A, anti-B, anti-RH antibodies. You would have all kinds of agglutination. It will be a major problem. So O negative is considered the universal donor. No A antigens, no B antigens, no RH antigens, no D antigens. RH is also known as D. Can be given to any other blood type in emergency when blood matching is not an option. And AB positive has all the antigens, and so that's the universal recipient. All right, so this person can receive any type of blood. They can receive B blood because they don't have anti-B. They can receive A blood because they don't have anti-A. They can receive RH blood because they don't have anti-RH. They can receive almost any type of blood. All right, so hopefully that makes sense. O can be donated to anybody. AB can receive from anybody. Right? And so these are This is a chart sort of putting that all together.